Hello everyone. In this video, we will talk about Daemon Security. So analyzing the security on the Docker host is very important because most of the attacks take advantage of the kernel vulnerability or could occur because some package haven't been updated. So here I review some tools for auditing the security of the Docker host. Now here we're going to actually cover topics like the Docker daemon and the app armor and the seccomp profiles, which provide kernel enhancement features to limit the system calls. Also, we'll talk about tools like the Docker branch security with Lin, which follows the best security practices in the Docker environment. I will also share with you some of the most important recommendations that can be followed during auditing and Docker deployment in a production environment. So probably the most important element of the Docker architecture is a Docker daemon. The process guarantees communication between containers and the traffic, and it is protected by the HTTPS protocol, which is an HTTP plus a security protocol. So Docker works primarily as a client that communicates with a daemon process called Docker. The process has root privileges and is socket located into the docker.sock file. So it's important to note that Docker socket exposure can result a privilege escalation. So you should always check the access permissions by the users that are using the Docker file. So only the root user has to write permissions, while the rest of the users should not be able to compromise the container. So let's go to the terminal and let's try to create a container inside another container on the Docker host. We'll be using the docker.sock process and we'll mount it as a volume. So you can simply do docker run -it -v for a volume, and the volume will be created into the var run docker.sock, and then let's do var run docker.sock, then let's do debian bin/bash. Okay, let's remove that space here and let's run the command. So once we run that, a new container has been created and now we're inside it. If I go to the Docker application, you can see that we created a Debian container and it is currently working and running properly. So once we are into the directory, we can simply write who am I, and you can see that we are root. And if we go to the bin bash and we do again who am I, you can still see that we are root. So that way we can see that the Docker container starts a new mount point in the host container. The second container connects to the host and you can check how effectively it is using the root user. So in that way we checked that we have a root access to the host from the process. So if I exit this container, okay, and then do clear, so we can run another command. So let's say docker run -it -v, and here I'm going to create the volume around the host. So I will do host, okay, and then let's do debian and then bin bash, okay. So now if I do ch root/host, you can see that we're actually going into the second container, which is into the first one, okay. So this is our host container, and if I do again here bin bash, you can see that we're going back to the previous container. Let's do now who am I, and you can see that we're root in both containers. So as you saw, the Docker daemon runs the root permissions, so it is important to limit the users who have control over the Docker daemon. I can give you a series of recommendations on how you should configure the access to the directories and the files to the Docker daemon. So in front of you, you can see a table with a list of default permissions of each file that is part of the Docker daemon. So obviously here we're having R for read, W for write. So if you're not familiar with the permissions and how they're selected, definitely check them out. They are an important part of every Linux distribution. So what you can simply see here is that the group that has access to those files here or those volumes are the root users, and they have those permissions there, right? So you can see that the permissions are actually quite limited. So at this point, we have reviewed the Docker daemon security and the default permissions for each service that this process is using. So those files, they represent the different services. And if you ever think to work with them, you can definitely use this table as a reference to what permissions you can gain. So let's talk about how we can audit files and directories on the Docker daemon. So the Docker daemon runs with root privileges, so all directories and files should be consistently audited to know all the activities and operations that are running. We can use Linux Audit Daemon framework to audit all events that take place on the Docker host. So the daemon framework has some very nice features such as the audit process and the file modification. You can monitor dynamically the system calls, you can detect intrusions, and also register commands by user. So the Linux Audit Daemon is a framework that allows you to audit events on Linux systems, and it is normally configured using just two simple files, the audit config and the audit results. So the daemon itself is the audit config, and this file configures the Linux audit daemon and specifies on where and how events should be traced. It also defines how to behave when, for example, the disk is full, or how many logs to keep at the same time. You wouldn't necessarily need to modify this file because the standard settings are normally appropriate for most of the systems. The audit results on the other side is the file that configures which events should be selected. So let's now go to the terminal, guys, and here let's see how you can use the audit tools. You can do that by a command called auditctl, okay, and you can see that I currently have this command installed, but if you don't have that set up, you can simply write apt get install auditd, okay, and this will pretty much install the tool. As I already have it installed, my installation is quite quick, but for you it could take about 1 minute or less. So in order to indicate to the audit framework which directory or file we want to observe by using the path. For example, if you want to check out the etc passwords, we can simply do auditctl -a exit, comma, always -f path equals /etc/password, okay, and then you can do -f perm equals to WA. And so when I hit enter here, also make sure that there is no space between the comma and the always. So when I hit enter, you can see that for me this rule already exists, but for you, since you write the command for the first time, the rule will be created. So let's now go to the rules file, and you can do that by doing cd etc/audit and then rules, okay. Let's go there, let's do ls, and here you can see that there is a file called audit.rules, okay, and after that let's open this file. So just use your favorite editor, and I will use vim audit.rules, and you can see that here we are having a few arguments. So here you can see the different rules, and those are the rules that enable you to audit certain directories. So you can copy and paste those rules right here, okay. I will attach those in the description of that video, or actually into the description of the whole section, so you can use them and write them right here. So let's save this file, okay, and then simply write sudo service auditd restart. So if we go now to cd_var, okay, then go to log audit, okay, you will see there that we have a file that is called audit.log, and let's check out this file. So let's do more audit log, and you can see that here we're having a huge log for the audit that has been completed on your Docker system. So you don't actually need to know what is inside this log, and I'm not gonna manipulate the parameters right here. and observe them. But the whole idea of that lesson is that you know how you can export log for a particular system by adding the rules and also knowing the location of the log that is generated. So this is how, guys, you can audit the entire files using the audit CTL tool. Thanks for watching this video, and in the next one we'll talk about the uppermore, which is a quite useful tool for assigning each running process on your system to a secure profile, and we'll observe things like file system access, network capabilities, and execution rules. That's it. Thank you very much for watching, and I will see you in our next video.